the ancient Indian thinkers what they thought about the elaborate system of motion and how the universe is running in, and what is the business of the kind of motion and the friction and the water and the water bodies and the waves and everything. If you have the same common queries, then please do stay in this video and learn what the ancient Indian scientists they contributed for the motion. Okay, thank you all. And if not subscribed yet, a polite reminder again that please do subscribe to my channel so that I will be further motivated. Okay, God bless you all. Just look into what is the video I made for the ideas and motion in ancient Indian sciences. Okay. Ancient Indian thinkers had arrived at an elaborate system of ideas and motion. Force, the cause of motion, was thought to be of different kinds. Force due to continuous pressure or nodan, as the force of wind on a sailing vessel. Impact, abhighata, as when a porter's rod strikes the wheel. Persistent tendency, Sanskara, to move in a straight line, Vega, or restoration of shape in an elastic body. Transmitted force by string, rod, etc. The notion of Vega in the Vaisesika theory of motion perhaps comes closest to the concept of inertia. Vega, the tendency to move in a straight line, was thought to be opposed by contact with objects including atmosphere, or parallel to the idea of friction and air and resistance. It was correctly summarized that the different kinds of motion, translational, rotational, and vibrational motions of an extended body arise from only the translational motion of its constituent, and vibrational motion or brahmana or spandana, but each particle of the leaf of an instant only has a definite small displacement. There was considerable focus in Indian thought on measurement of motion and units of length and time. It is known that the position of a particle in space can be indicated by a distance measured along three axes. Bhaskara in 1150 AD had introduced the concept of instantaneous motion or Tatkaliki Gati, which anticipated the modern notion of instantaneous velocity using differential calculus. The difference between a wave and a current of water was clearly understood. A current is motion of particles of water under gravity and fluidity, while a wave results from the transmission of vibrations of water particles.